We want to talk about slope and how to find it given 2 points or given a graph. So given 2 points, we use a formula. Now this formula comes from talking about our rise, meaning our vertical change over our run. So in this situation, we can see our rise and our run in this graph because the numbers are small enough to give us that. But sometimes they're too large to just count, like some of us are very willing to do. So what we have to do is use the actual coordinates. In this example that you see here, my 2 points are at -4, -3, and my second point is at 5, 1. I don't want to just, let me try to figure out my color change. I don't want to just start choosing numbers to plug in here. I have to be aware that this is my x1 and this is my x2. Let's use a nice green. Here's my y1 and here's y2. It's very important that when you're still starting off with these concepts, you label what you can. So my y2 is 1 minus, and y1 is -3. I don't remember which blue I used. My x2 is 5. My x1 is -4. My calculations would tell me that this is 4 over 9. That's my slope. So let's test this out visually with our rise and our run. If I count my rise, I count 1, 2, 3, 4. And my run is 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is just a check to see that we did this correctly. Every time you want to find your slope, you plug it into this formula. If you can count it, you can count it. Or if you're given the function, well, I shouldn't put y, I should actually put f of x, because that's what we all need to become comfortable with. If you're given the function, then you can simply say, what is my number multiplied by x? What is my coefficient? That is my slope. So in this graph here, my equation would be 4 over 9x plus, and b would be a very specific number. It's a decimal. So we're just going to keep it as b for now. That's how you would find it. So let's briefly talk about where slope comes from. It's a ratio that we use for calculations that are going to seem and show that they're very important to you later. Right now, since we're just talking about the theory and the idea of the concept, it's not super clear, but as we start getting applications, you'll see why this ratio is, why it's important that slope is a ratio. It's a rate of change, just as a general kind of hint to that varies depending on the context of the problem. So where do we get the denominator and the numerator? Well, let's talk about our numerator first, our rise, our y change. So in this example that I have here, my y starts at -3. That's where my y value begins. And it ends at 5. So I want to find the change in this interval. How much did I move? And that's where I would do my greater value, which is 5, and I would subtract my lower value of -3. Now, understand this is a different problem than the one you just had. And that would find my rise. Then, to find my denominator, I'm talking about the change from -6 to 2, meaning the change in this interval. So I'm going to do the same exact thing. So I have a fraction, and my x2 is my second value, minus my x1, which is -6. It's my run. And from there, I would simplify this to find my actual slope in this problem. Which, funny enough, in this problem, my slope is actually going to come out to be 1, meaning that actually, if I chose two different points, if I chose the point here and the point here, I would get a rise of 3 and a run of 3. It works the same way no matter how many points I choose. One is kind of a special slope. It's going to look very nice, very clean, but it still functions the same way. You're still going to use the same formula where you calculate your change from your x2 to your x1 and so on and so forth. Hopefully that helped.